Alright guys, so we're back here working on the Ford Fusion taillight Ghosted Retrofit, and these are actually not OEM Fusion lights. These are aftermarket Mondeo lights. Basically, in the USDM market you have the three different trim levels: S, which is the lowest, the SE, and then the titanium. Over in Europe, it's not called a Fusion, it's called a Mondeo, and they have their own kind of iteration of things, obviously, in that market. One of those is the tail lights is a little bit different, so they function a little bit differently. The turn signals on the Mondeos are amber, where in the USDM market on the other three trims I mentioned, they are all red. So one thing to note here, I took out the driver board on these because I was going to start making a video here on how to basically hack up the OEM LEDs. In this case, I guess I shouldn't say OEM because, again, these are aftermarket. They're not the OEM boards from an OEM Fusion taillight, so let's just say the stock LEDs. So I was going to show how to basically hack up the stock LEDs and utilize them in a sequencer. In this case, Ghost or Quartzo Motion, not sure yet. Whatever I've left in stock over here in my little parts container. So, first thing we're going to have to do is kind of dive in and see how these boards work, right? Are these wired all in series, in parallel, a array of some sort? Also, what are these boards doing, right? Are they constant current driving? What's the voltage in? What's the voltage out? Etc. But the first thing I noticed was the board on the left is a driver that came out of an OEM set of titanium tails. The driver on the right is a board that came out of this set, which again is the aftermarket Mondeos that you can find all over the Chinese market. I mean, the shape is similar, obviously. It needs to all sit in the same housing and whatnot. The concept looks the same. I'm no electrical engineer. I'm just learning about, a lot of this more in-depth circuitry and whatnot, but it looks like you have the same basic, I guess these are transistors of some sort, right? You got 2 and 2. The American USDM made board, however, has a lot more circuitry, it seems, a lot more resistors and such compared to the aftermarket Chinese one. So that's interesting. Check out the back side of them. Check out the verbiage on them. So the USDM one says CD391 RCL tail ECU. This one says XL CD391 RCL tail power. So a little bit different verbiage, but sound like they're saying the same thing. So anyway, interesting stuff. I thought I'd kind of show that. And secondly, what I kind of wanted to show between these two boards that I just explained was they are regulating differently, which tells me that the LEDs that are being used, or at least how they're wired, are different. I'm sure that these aftermarket LEDs they used are not the same high quality LEDs that the Fusion OEM taillight's using, and I'll have to dig up that same equivalent circuit board so we can compare them. But let me show you what I mean. So let's power up the aftermarket board and see what we're getting power wise. So I got 12.8 volts coming in, and we have nothing hooked up. We have nothing apparently. Alright, what's going on here? Oh, I guess I should hook up the right leads to the right contacts. The grounds are on the outside, the power's in the middle. Alright, so now when we check, again, we have 12.8 coming in, and we have 12.1 coming out. Now let's also check the amperage draw when something's hooked up to this board. $550 milliamps. So it looks like this board is probably current limiting at 550. See if I can, or current regulating rather. It's a constant current driver. See if I can kind of hold this and adjust my input power at the same time. You know, it'd probably be easier if I just stick it in the connector. Maybe. Alright, so we got our 540 coming out. I'm adjusting down to 11.5 volts, constant current. The current draw stays the same. Let's go up to 13.5, 14. Yeah, so it's a constant current driver. Alright, now let's check the specs on the aftermarket, the OEM board. That gets quite hot too. Borderline uncomfortable to hold if it was any hotter. Alright, what do we have here? We had the power in the middle and the ground on the outside. Let's go back to our same 12.6 volts starting. Okay. Alright, on this USDM board, we're only getting 340 milliamps draw. So that's actually interesting. We're getting lower current consumption on the proposed better quality board. However, the LEDs may be wired differently on the US made LED array. So just because you're getting higher output on the aftermarket one doesn't necessarily mean that the lower output on the USDM made one means anything. We'll have to compare the actual LEDs and such. Check the voltage off this board. So at the 12.6 in, we're at 12.06. So from what I remember, it's the same amount of a voltage drop after going through the driver here. Also, this is not even warm to the touch, so that's interesting. Alright, so now we're looking at the inner LED boards that basically are the brake light and the turn signal. Now, we have the aftermarket one on the left from the Mondeo, and we have a titanium one on the right. So, again, boards are pretty much, they look the same, right? Same design, same shape, as you'd expect. The LED count is the same, except the OEM board has 2 extra LEDs on this corner over here. And I want to say those are for the rear fogs, but I'd have to check on that. Don't quote me on that one. I guess one interesting thing to note is 1, 2, 3, 4. It looks like we have like 4 transistors here, assuming that's what they are. And there's only 2 on the US made board, so that's interesting. On the back side, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, same amount of LEDs on the back side for the turn signal. So it's just the brake light configuration of LEDs that are a little different, assuming that these are dedicated for rear fog. But again, I'm not sure. I think they are. Pretty sure they are. Alright, so here's kind of the difference on these two. I'll call them the brake and turn signal board. First, let's look at the Mondeo one, the aftermarket one, right? So you have your brake lights on the bottom here. Then you have your turn signal, which are amber, up top. On the titanium model here, which again is the one made in the US, Ford Fusion, you have your brake lights, which are LEDs on the top and the bottom. Then you also have those two individuals, which I think, like I said before, are kind of just the fog lights, rear fog lights. So there's the differences in these two boards. Could explain, you know, similar concept on the differences of these drivers too, even though these drivers aren't even powering these. These are all the driver, the regulation and everything is all done on this whole board by itself, which is why I just supplied 12 volts to the boards directly. These drivers here are only for controlling the parking lights here. So let's kind of look at how the LEDs even work and the optics it uses inside this tail light. So you have that middle board hooked up here, which we just went over previously, and you have LEDs on the top here, which are the turn signal, and LEDs on the bottom here, which are the brake. So that board basically slides right in this slot here on the front bezel, and there are little reflector bowls on the top and little reflector bowls on the bottom, where each LED is basically shining through the holes into that reflector pocket, and that's really what gives the output to be seen. Without those reflectors, I mean, those LEDs are shooting nothing. I'll have to measure. Not really sure what LEDs these are here from China. I'm pretty sure on the USDM board they're probably Osram somethings, but I'd be curious to know, you know, what the current draw is for each one of these LEDs. I'm assuming it's probably no more than 150 and probably more like 60-ish. But if you didn't have these reflector bowls, obviously, I mean, that's really what's working the magic to be seen as a brake light and a turn signal in a bright sunny day. So as for the outer ring behind this nice dimpled diffuser, I think that has a name. Is it Myrad? Triad? No, I think it's Myrad. This material here with all the little triangles, the optical output that it gives off with light behind it. I forget what it's called, but it's a certain material. That's the ring for the parking lights, and the concept's the same thing, right? This ring here sits around inside, gets bolted on in the middle around this board, and this whole thing around is you know, reflector bowls. So this is actually a really good tail light to do some awesome stuff on, some awesome custom stuff on. There hasn't been too many Fusion taillights out there as far as expensive builds that I've seen, maybe 2 or 3. The one thing that does suck is I would love to make this a Ghost V5 and Blue Ghost dual zone sort of taillight and kind of show that off. But so let me give you my idea. Basically, behind the ring diffuser would be your Blue Ghost, which would run the parking light output as well as a turn signal. You can even do a reverse light as well, but I would pair that up on the inside with also the turn signal. But the inside here would also be a dedicated brake, because I mean, you don't want to rely on Blue Ghost addressable LEDs for your brake, even if you're, you know, shooting them through a optical mechanism like these little reflector bowls here. I just still want to, you know, you don't want to trust that. They're not bright enough. They're not reliable enough. So you get the best of both worlds, though, if you're gonna, you know, Ghost good quality semi-bright LEDs with good optics, along with addressable LEDs and the Blue Ghost to provide cool effects for show modes and car shows and all that good stuff. But back to what I was saying. Basically, as cool as that would be, it's perfect for it. The lens, right? The lens on these. Oh no, PCB boards falling everywhere. The lens on these are not all the way clear. So the Blue Ghost behind the red lens, you'd lose every other color anyway, or else it would be inaccurate. So if anyone knows how or who I can contact to get a totally clear lens in this shape, and I could send a lens in to them to get a totally clear lens made, let me know. Alright, so I'm struggling here, trying to trace, even with the magnifying glass and whatnot, trying to trace the copper lines to see how these are kind of wired. I mean, it'd be real easy to just, you know, forget the stock LEDs and let's wire in our own LEDs all the way around and control these, but it's kind of not efficient, right? Because we already have perfectly good LEDs on a board in perfect alignment with the reflector bowls. So you're going to go through a lot of extra effort wiring up kind of the same thing for no reason. However, you do gain out of the bicolor LEDs, you know, when we animate them, we'll be able to do 2 different colors instead of just one. These are obviously all red. So there's that aspect, but I kind of want to cut all these sections, all these join sections off. Then we'll be able to control, we'll just use our own LED driver to control each individual section. But then, you know, you're controlling so many big groups of LEDs that the animations aren't going to look that great compared to controlling a lot more of them individually. So I don't know, kind of torn. I mean, obviously a third option would be we could just cut all the lines here on each LED and separate them all out, and then solder on our own wires to each one and control them that way. But I don't want to have to deal with resistors and all that garbage. So I don't know. I'll figure it out. I'll try something out, and look out for the next part 4 of this.